Okay, so let's do a Hess's law problem. So here we have a Hess's law problem. And in a Hess's law problem, what you got is you got a chemical equation whose delta H you're looking for. If you look at this problem, it says calculate the enthalpy change, the delta H of the following reaction. Okay, so you have the reaction ammonia plus oxygen goes to form NO and H2O. And this is balanced. The equation is balanced. And you're given here, this problem here is giving you three equations that are supposed to help you. A lot of times you'll find two, but sometimes three, sometimes four, really depends. Remember, the whole idea in Hess's law is you want to go ahead and add these up so that they give you this. Now, sometimes, most of the time, they don't just add up directly and give you this, right? Because if you add these up, remember whenever you add up chemical equations, you take all the reactants from all the equations you're given, and you make them part of the reactants of a new equation. You write an arrow, and then you go ahead and take all the products and put them on the right side of the arrow. So here I would have three products. I'd have 6 reactants and 3 products. And that will give you this. This has got only 2 reactants and 2 products. But remember, we can manipulate the equations you're given. We can either reverse them, and when we reverse them, put the reactants as products and products as reactants. What you do is you change the sign of the delta H. Or we can multiply them by a number. When you multiply them by a specific number, then you do the same thing to the delta H. Then in the end, once they add up to the overall equation, you do the same thing to the delta H's, you add them up, and then you get your result. So let's do this one. I'm going to start off by changing the color here on my pen, because I want to go ahead and go over a little bit of strategy. Sometimes people look at this and go, how am I supposed to get this from these guys right here? But as you can see, these equations contain some of the substances here. So for example here, NO is going to be a product. Go on here. NO is going to be a product. And NO is found right here. And it's the only place NO is found. So we only find it in the first equation and not the second or the third. So the only way I'm going to get 4 NOs on the right is to leave this equation as is, but multiply it by 2. So I'm not going to reverse it, but I'm going to multiply it by 2. So that's what I'm going to have to do to this one. Okay? Because that's the only way you get 4 NOs on the right side once you add these up. We're also trying to get 4 NH3s on the left. And you can see that this is the only place right here where we can have NH3s. So this equation right here, the first one does not have any NH3s, the third one doesn't have any NH3s. The only way you get 4 NH3s on the left is to take this equation and you flip it, puts it 2 NH3s on the left. But since we want 4 of them, we're also going to have to multiply it by 2. Okay. Now you're going to notice, and I'm going to change the color right here to show you something a little different. We also want 5 O2s. And we have 5 O2s on the left. Now O2 is available from here, and O2 is available from here. We're not going to use the O2. We're going to let the O2 kind of fix its way on its own, or while fixing the others, we'll let the O2 kind of settle on its own. We don't know how we're going to get the 5 O2s. Is it going to be 2 from here, 3 from here, or is it going to be 3 from this first equation, or 2 from this other one, or 4 from the first one and 1 from the last one, or is it going to be like 6 from here and the O2 needs to go on the right here, and we're going to have 1 here, so you take 6 on one side, 1 on the other. You subtract 1 from 6 because one of the oxygens here is going to cancel out one of the oxygens on that side. That'll give you the 5. We don't know. We don't know what the combination of O2s are that are going to give us the 5 O2s. So that's why when you see a substance involved in more than one of these reactions, you leave it alone till the end. It'll probably work itself out. We do see that we have 6 H2Os, and H2O only appears in this last equation. So I'm already getting the idea that we're going to have to multiply this H2O by 3 in order to get 6 H2Os. So let's do those. Let's go ahead and do these manipulations and see what we end up with. So I'm going to go back to a black pen. My problems, the colors were just to strategize. But see, I've been looking at what what substances I need on the reactants or products, what's the coefficient I'm going to need, and where I can find them in these reactions. Okay, so let's see. In order to get our, in order to get our 4 NOs on the right, I'm going to have to take this 2NO and I'm going to have to multiply it by 2. We have to do it for the whole equation. So I go ahead and multiply the whole equation by 2. I end up with 2N2 plus 2O2 goes to form 4NO. Right? The second equation, we wanted the NH3 on the left, and we wanted there to be 4 of them, not 2 of them. So we're going to flip it and multiply by 2. And when you do that, you're going to end up with 4 NH3s. And that's going to turn into, we multiplied it by 2, right? So 2 N2s plus 6 H2s. Okay, so this equation flipped gives us NH3 on the left and N2 and H2 on the right, and then multiplied by 2 just doubles all the coefficients. The last one, we said we needed 6 H2Os, right? We needed 6 H2Os over here. We have 2 H2Os, so the only way we're going to get 6 H2Os is by multiplying this one by 3. If I multiply this equation by 3, I'm going to end up with 6H2 plus 3O2 is going to go to form 6H2O. Okay. So now let's see what happens when we go ahead and add these together if we get our equation up here. In order to try to get rid of some of the mess, what I'm going to do is I'm going to have some stuff canceled out, because normally what I would say is go ahead and add up all the reactants, put them all in one line, and then put an arrow, and then add up all the products, put them all in line, put an arrow. And anything that appears on both sides, cancel it out. But you can already see that these 6 H2Os here are going to be on the left, and these 6 H2s here are going to be on the right. So they're going to cancel. But I say H2 on this one, they're so these guys are going to cancel. Also with the N2s, these 2 N2s are on the opposite side of the 2 N2s over here. These guys would be on the right side of the arrow. These guys would be on the left side of the arrow when we add them all down here. So I'm going to go ahead and cancel those guys. We're not going to have to worry about those. Now I put everything left. I'm going to write that down. And so I have here my 4 NH3s, which is what I wanted. 4 NH3 stays. And here I'm going to go with, I've got 2 O2s and 3 O2s. So since they're on the same side, I add them together. If they're opposite sides, they cancel. But since they're on the same side, I add them together. So that's 3 plus 2 is 5 O2s, which is what we wanted. And that's going to end up giving us 4 NOs right here. 4 NOs are still there. And we also, one thing that's left is a 6H2O. And look at that. We ended up with the chemical equation that we wanted right here by adding these up, adding these three equations up after we'd manipulated them. Now, in order to get these, what we did is we went ahead, and the first one I multiplied by 2 to get these coefficients. The second one I also multiplied by 2, but that was after flipping it. So really, I multiplied by -2. And the last one here, I just multiplied by 3 to get my 6H2. So by doing this to these equations, I got these, and once I added them up, it got me my overall equation. Remember, what we're looking for here is, we have this equation. We need this equation. What we want is the delta H. What is the delta H? Well, in order to get the delta H, what we're going to do is take the delta H's of these 3 equations, and whatever we did to the equations here, mathematically, we're going to do the same thing. So the delta H of the first equation right here is 1806 kilojoules. So I'm going to multiply that one by 2, because that's what we did the first equation. The second one here, we multiplied it by -2, because we reversed it, multiplied by 2. So we're going to multiply this one by -2, multiplied by -2. And the third one, we multiplied it by 3 in order to get our equation. That's what we're going to do. And let's see, let's do some calculations here. We've got 1806. Multiply that by 2, and you end up with 3612. So let me go ahead and write down these numbers here. Equal to 3612. Okay. Now for the next one, negative 91.8. I'm going to go ahead and take 91.8, negative 91.8, and multiply it by negative 2. And what I get is, since there's two negatives in there, I end up with a positive 183.6. It's 183. That there, just remind me. And this last one right here is 483.7 times 3. It's negative also. So remember, you have to be very careful with the negatives and positives here. 483.7 times 3 is going to give me negative 1451. Negative 1451 kilojoules. Okay, so these are the delta H's once you've taken these equations and manipulated them. So these are the delta H's here for the equations in this. Now all you have to do is add these guys all up together, right? And so I get 3612 plus 183.6 plus negative 1451.1, and I get 2344. Down 2344.5 kilojoules. And that right here is our answer for our equation. The delta H for this reaction is 2,344.5 kilojoules, and really kilojoules per mole. For this equation right here, because we took the delta H's of these equations that we used, and we manipulated them so we can get the equation over here. Because this is a state function, and state functions allow us to do that. Okay. All right, so I hope that wasn't too complex. Usually, if you only get two problems with two equations, you just manipulate those two equations. Once again, you can reverse them, you can multiply them by a number, you can even multiply them by a fraction. Whatever you do that gets you your overall equation, whatever you do to these equations that you're given, you do the same thing to the delta H, and then you add them up, and that gives you the delta H for your equation. Here we can mention that this is an endothermic reaction because the delta H is positive. Okay. All right. So hopefully that was helpful to you.